Another hazard relates to the lack of regular system updates. Also, other software installed in a computer is often left outdated. This issue has a bearing on security as computer holes and vulnerabilities are being detected practically on a daily basis. There's no piece of software that's perfectly secure. A while back, a certain developer announced that he'd pay $100 out of his own pocket if a bug is found in his program. This is the only known case when someone publicly claimed that they created a perfect application. The program in question was quite basic, and this happened 25 years ago. The reality is that programs do and will have bugs. Some of these bugs can put the program or the entire system, and perhaps even the user, in jeopardy. It's essential to remember about regular software updates. Software developers take different approaches to detecting and eliminating known vulnerabilities. As far as Microsoft is concerned, the company treats this issue with considerable respect. Keep in mind a simple security rule we've mentioned earlier. If you don't install security updates and patches regularly, you practically give up control over your network. The next presentation will show why this is so crucial. We'll see how easy it is to take over a system that has known vulnerabilities or known security holes. We'll switch to the Metasploit environment and run the program. The framework was used before in one or two case studies. Metasploit is, broadly speaking, a tool, a framework used for testing software security. The basis of the program is a database that contains known security holes with descriptions. Exploits, programs that automate attacks, have been developed for many of the vulnerabilities. Metasploit's database also contains exploits in their descriptions. A framework user only needs to choose a target computer that is potentially outdated. Next, an exploit has to be selected. Using it, you can execute the exploit remotely and attack the system. One of the most popular exploits makes use of a security hole in Windows File Server. The list of exploits in this version of Metasploit, the program hasn't been updated for 11 days, includes a vulnerability that exploits a stack buffer overflow in Windows SMB. Metasploit allows you to view the provider of the exploit and includes a list of susceptible operating systems. Note that one Windows system comes in many language versions. Because this exploit uses a buffer overflow, it has to know the memory addresses used for some system libraries. The addresses can be different depending on the language version of the system. Our attack is universal and covers most of the language versions. Let's see now if the computer we want to connect to is vulnerable to the attack. We'll use the presented exploit. We've gone through the first part of the attack. We've selected a vulnerability and a corresponding exploit. Now it's time to specify the targeted computer and set up the address of our computer, the address we want our victim to connect to. The address will be configured globally as a localhost global variable. We'll need our own IP address. It can be obtained, for example, by typing the ipconfig command in the command line interface. Our address is 192.168.0.56. One variable is already set. The second will be the address of a remote computer. All attacks are run on computers we control, so it's not a problem to check the address of a remote computer by typing the ipconfig in a computer's command line interface. The IP address of the remote computer is 192.168.0.55. Let's set a local variable, since it's possible that we'll be changing targets. Let's now view the configuration of the attack. The attack is launched on a computer with the IP address of 192.168.0.55 on the port 445, which is the default port used by SMB. It seems that so far, so good. The second part of the attack is selecting a payload, the actions that you want to execute after you break into a remote computer. Let's assume that the payload is making a remote machine connect to us. This would be proof that we've taken over the computer. Let's use one of the predefined code snippets. We're almost ready to begin. Let's see if we can manage to take over a remote system. It seems that we've succeeded. A session is open with a 192.168.0.56 host. This means that the attack has been launched successfully. We can now check if we can connect to the computer. As you can see, a connection can be made. You can now launch remote programs of your choice in the system. Let's go back to the command line interface and execute a code remotely. For example, start a calculator. A process has been launched. Because we physically control both computers, we're able to check if the remote system really runs a calculator. As you can see in the Windows Task Manager, the calculator is launched. What would actual attackers do in our place? The attackers would probably be interested in sensitive data and take a snapshot of login details and other confidential data being provided on a form or a website. An attacker could also acquire additional information on the remote computer. Scraper is one of the scripts that gather system data during the reading of registry keys. After Scraper is launched, the program will try to gather information in the session that was declared, session ID 1. If the program succeeds, all configurations will be written to a file and sent to us. The attack will probably succeed. Registry keys are being exported. This process takes quite long. This is because the computer we targeted has a low processing power. If we had malicious intent, after the process is completed, we would also need to hide the fact that we had broken into the system and harvested some data. The information on intrusion is probably recorded in system logs, in the system security log in particular. Also, other logs can contain traces of the attack. In that case, let's try to wipe all system logs. If a victim browses through the logs from time to time, they'll notice that a deletion event has been logged, which could be a problem. This would be the sole information that points to a successful attack having been run. The last thing we'll want to do is exactly that, clearing event logs. As you probably all know, Windows has 3 event logs: Application, System, and Security event logs. As you can see, all entries in the logs have been deleted. Using several Metasploit commands, we've managed to take over a machine that wasn't updated regularly. We were able to monitor the processes launched on a victim's computer. We also run our own processes and gathered system configuration information. This could be beneficial, for example, if we wanted to break into another computer on the same network. At the end, we also wiped the security logs. That's it for this case study.